This video explains the essentials of hypothesis testing. The very first question is that why do we need hypothesis testing? Especially when we have all these tests like mean, median, standard deviation, quartiles, percentiles, skewness and kurtosis, etc. Then why do we hypothesis testing? Well, we do hypothesis testing if we are only concerned with statistical estimates of a group. Then these measures, statistical measures, they will be okay. We are fine with them. However, if our objective is to make an inference for the broader population, which means we are taking measurements from a sample and our objective is inference for a broader population, then we need to do hypothesis testing. Let me explain it with an example from the textbook. Suppose FTC, that's Federal Trade Commission, they believe that one can of coffee, it bears on its label the content as 3 pound. But FTC director believes that it's not possible to have exactly 3 pounds, and FTC believes that possibly the contents are less than 3 pound. But of course they are not sure, and for this purpose what they do is that the only available thing for them is that they can take a sample and they can test it, and based on those tests FTC can make an inference about broader population. So what they do is that they take a sample, let's say they take a sample of 30 or 35 cans, and then they measure contents, and then they get all the statistical estimates like mean. And however, because their objective is not only just to measure the contents of those 30 or 40 cans of coffee, but they want to make inference about several hundreds and thousands of coffee cans that are available in the market, and they want to know whether the claims on the label they are correct or not. Therefore, they need to do hypothesis testing. There are two types of hypothesis. One is null hypothesis, and the other one is that is exactly the opposite of that one, is called as alternative hypothesis. Null hypothesis is also called as a tentative one, or we could say the tentative conjecture is called null hypothesis, and the opposite of that one is called alternative hypothesis. In a scientific study, it's very important to formulate a right set of hypotheses, and for this, context of the situation is very important in determining how the hypothesis would be stated. And some of the guiding questions that a researcher should always think is that what's the purpose of the study, what's the purpose of collecting data, and what conclusions researchers they want to establish. And for this one, usually when researchers they start with null hypothesis, and most of the time they make this type of hypothesis that claim is usually considered true. So for example, even an accused person is considered innocent unless proven guilty. So for example, in this example of coffee, for which FTC believes that its contents are less than 3 pounds, 3 pound is the quantity that's mentioned on the label. Their starting point is this assumption, or the null would be that contents are 3 pounds or at least 3 pounds. So that's one type of hypothesis that's usually made. And then another one is that there is usually, it's assumed that there is no relationship or difference, or mean difference is 0. For example, if it's a test about correlation or regression, then we will assume the null hypothesis would be that there is no relationship between two variables. That will be in correlation and regression. If we are doing t-test or ANOVA or chi-square test, which are meant for comparison, then we will assume that two or more than two variables, they are the same, or the mean difference between them is 0. In other words, they are the same. And alternative hypothesis can be opposite of that. Another way to formulate hypothesis is to start with alternative hypothesis and then go backward. So for instance, in this case, in the case of coffee, we can imagine, let's say for instance, we can start with alternative hypothesis, and this is the one that I usually prefer. So for instance, let's say the researcher or FTC director, they want to test, they believe or they doubt that the contents of coffee cans are less than 3, and that's the purpose they are doing this study, and that's the purpose they have collected sample. So in this case, they can start with alternative hypothesis, and they can state that alternative hypothesis is that contents are less than 3 pounds, and so that becomes alternative. And then the null hypothesis would be exactly the opposite, and the null hypothesis would state that contents of coffee are either equal to or more than 3 pounds. So in this case, the starting point will be alternative hypothesis, which states that mean contents are less than 3, and then going reverse, null hypothesis would be that the contents are at least 3 pounds. Another example of this type of approach to hypothesis formulation is this example. For example, some researchers, they have developed a fuel efficiency system, let's say an injection system, and they believe that this fuel system is more efficient. It increases mileage, and their claim is that its new mileage with the new system will be at least 24 or greater than 24, and which also means that the existing system, it gives mileage of less than 24. Now a researcher can formulate hypothesis in a number of ways. For example, if a researcher starts a hypothesis starting with alternative hypothesis and then going reverse, in that case their alternative hypothesis would be that the mean efficiency of the new system is greater than 24, which means their belief or the system or the one for which they are seeking empirical support. So that will become alternative hypothesis, and then null hypothesis would be exactly the opposite, which means that the efficiency of the new system is less than or equal to 24 mile per gallon. Another way to formulate this hypothesis would be that researchers assume that they start with null hypothesis, and their null hypothesis would be that the new system is as efficient as the existing one, and in that case null hypothesis would be that there is no difference, they are the same, the old system and the new system, they are the same, or the difference in the mean efficiency of two systems is equal to 0. And in that case, then alternative hypothesis would be that no, there is a difference between them, or the mean of difference of the two system is not equal to 0. In any case, developing null and alternative hypothesis can take following forms. So the first one is that in which it's assumed that null hypothesis is mu is greater than mu sub 0, and alternative would be exactly the opposite, which would say that mu, that's the sample mean, is less than mu sub 0. And second type would be that where this inequality sign is in opposite direction. It says that mu, that's is less than mu sub 0, and then alternative hypothesis would be exactly the opposite. And please note that here alternative hypothesis is without any equality sign. So over here in null hypothesis we have this equality sign, but over here there's no equality sign, but just the symbols, which is less than or greater than. And the third form is that whereby a researcher assume that, or they formulate research hypothesis by believing that the two systems or two variables they are equal, and then alternative hypothesis would state that they are not equal. Now the first two, they are called as one-tailed test, because in this case, for example, the value the value of that critical test or p-value, it will be on one side, on one tail, either on the right or on the left. And however in this case it will be on both sides, so this is called as two-tailed test. Now the next thing is that, for example, let's say here's a practice. In RStudio there is a data that's called iris data, and in iris data there are two types of variables. One is sepal length and the other is petal length. And let's say you want to apply t-test on that, because these are two variables, and therefore t-test would be a two sample t-test would be more appropriate. Now the starting point would be formulation of hypothesis, and the question is that what should be hypothesis. Now there are two scenarios. One thing is that in which a person or researcher does not know. For example, actually when you look at the data, petal length is definitely larger than sepal length. Sepal length is shorter and petal length is larger. So let's say if a researcher does not know anything about sepal length or petal length and they want to compare it. So in that case, a researcher may make a null hypothesis that would be that sepal length is equal to petal length, and in this case their alternative hypothesis would be that no, they are not equal, and that will be bidirectional, which mean it could be either on the right tail or on the left tail. Or another type or another way to formulate this, the same thing could be that sepal length and petal length are the same, and this is just a different way to rephrase the same problem. And the last one is that it says that difference of the mean of sepal length and petal length is 0. So which means like it's the same thing, just they have been rephrased differently. And so that's one scenario. The other scenario would be that where researcher believes researcher has already seen the data and researcher knows that petal length is definitely greater than sepal length. However, researcher is not sure that if this observation, which means petal length is greater than sepal length, is it consistent, or whether he would observe the same phenomena across the population, or is it something just that happens in isolated cases, and this phenomena exists only in sample. So the researcher knows that petal length is greater than sepal length, but researcher wants to be sure, be confident that this phenomena exists in the population as well. Now in that case, researcher can start with alternative hypothesis, and alternative hypothesis would be that petal length is greater than sepal length. That's what a researcher knows, that's their belief, and then they can go reverse to null hypothesis, and null hypothesis would be exactly the opposite, in which a researcher would say that petal length is either equal to sepal length or less than that, or they are of the same length. That's the same thing that we discussed in first scenario. Now, no matter whatever hypothesis it whatever shape this hypothesis takes, when you will be collecting data and you will be applying test, most probably two sample t-test, and then you will be getting p-value, and using the same data for any of this scenario, p-value will be very small. You will come across the same conclusion. P-value will be very small, which mean if you are dealing with this hypothesis, null will be rejected in the favor of alternative, and also null would also be rejected here in the favor of alternative hypothesis. In hypothesis testing, interpretation of results comprises two parts, and first part is that you look at a statistical test. For example, mostly it's like, for example, in this case of sepal length and petal length, the first step is to look at their means, and that's the most important parameter. You can also look at other type of parameters like how much standard deviation exists, etc. That's the first part. And the second part is that you want to be confident that whether these differences they would also exist in the population or not. And for the second part, we use p-value, that's a probability value, and that probability value is used to reject or not reject null hypothesis. Probability values, they are meant to give you confidence. They are not meant to tell you which one is larger. If you want to figure out sepal length or petal length, whichever is larger, for that you will consult mean or average. But probability values, they are meant for how much confidence you have in findings. And then we have usually whenever we are interpreting results, we have different statistical results. For example, in t-test we have t value, in ANOVA and chi-square value, a correlation value and a regression value, like that. Normally what happens is that when these computed values, they are greater than the critical value, then we reject the null hypothesis. However, the most important thing is that, and that's very most commonly used, is that if p-value, probability value, is less than 5%, then we reject null hypothesis.